Hello and welcome to another exciting episode of the Being an Engineer podcast. Today we've got James Davis, better known online as FluxBench. He's a maker, engineer, and educator who helps people bridge the gap between electronics tinkering and building real functional products. Through his YouTube channel and community contributions, he breaks down complex concepts from ESP32 projects to embedded design into approachable lessons that keep the magic smoke inside the components where it belongs. James, thank you so much for being with us today.
Thank you so much for having me. I'm very excited.
All right. Tell us a little bit about the magic smoke first. For those who aren't familiar with that reference, what the heck is the magic smoke?
Well, for those who don't know how to make electronics, you get magic smoke, you put it inside these little black squares. And the thing is, you only really see it when they break and you go, psh, and that's when the smoke releases. It's the only time you can actually see the smoke. But I try to teach people how to prevent that from happening.
Yeah, it's the smoke that makes the electronics work, right? As long as it's inside.
It's the magic smoke, yes. But it's super hard to put it back inside. I've tried.
Yeah, right. Once it's escaped, you're done. It's not going back
exactly. Yeah, but fun enough, as a beginner, you have to kind of burn up some stuff until you plug something in and see the little poof and go. It's like just instant disappointment and instant teaching right there. And so like you put in a different size resistor, you plug it in, it pops. You put in a different resistor, you plug it in, it pops. And you go, maybe I should actually do some math and find the right resistor.
Actually do some engineering, right?
Actually do, some engineering.
So James, tell us, what made you decide to become an engineer?
Ooh, this was the question I was most nervous about because I'm not sure if I am an engineer. So I've been thinking about it, and if you do doctor things, but you're not a doctor, you're not really a doctor. Like, you didn't go through the school, you're not like the official doctor. I do engineering things, but am I an engineer? That's what I'm not sure about. So I work with engineers, I do engineering things, but I just like making stuff. Been building with Legos my whole life. Like, my mom would like come in and be like, honey, do you want to have a friend over? I'm like, no, just building Legos. And so just continued on, potato guns, motorcycle jumps and ramps. And so I don't know if I'm an engineer. I just build things.
So I'm going to push back on that a little bit. For anyone who's watched your channel, I think they will agree that you are an engineer. And these days, I think engineering, I mean, of course, there's the degree, right? But like,
yep.
I don't think a degree is necessary to be an engineer these days. There's so many sources from which you can learn the curriculum, the information that you need. And really, engineering is not about having a piece of paper. It's about being able to build and create things. And you very much are able to do that.
So I work with people who make amazing things that like prevent us from dying and like keep us safe. And those, like, I just kind of want to say, like, I appreciate that level of engineering. Those people who like check the resistor math before they plug something in, poof goes the magic smoke. So as much as I do engineering stuff, I kind of want to like dedicate a little bit of respect for, I don't know, the hardcore engineers. I don't want to call it like the real engineers, but whatever the word is, I appreciate people who have gone through like stress mechanics, like people who know how bending forces work on an I-beam and spent a whole month just going crazy before that test. So
yeah, I appreciate that. Yeah, for sure. I've worked with a lot of engineers in my career, including some who are currently at my company Pipeline, who are amazing engineers, but they didn't go to school to get an engineering degree. They kind of just picked it up here and there on the job, personal projects, things like that. So let's go back to, you mentioned like building Legos and things like that growing up. What was it that motivated you to get into building and creating and engineering?
I don't know anything else. That's the honest truth, is that my first memories are with me in a Lego table in a big pile of Legos, and like, good luck telling a 2.5-year-old use the instructions. So I just remember playing with Legos all day long. And then after that, I found out wood and nails. Like, I wanted to see what was inside my bike. So cut that in half, and there's nothing inside the bike, but it broke the bike. So I I think the best thing that I've gotten is just hands-on knowledge. And like you're saying, people just pick it up. I think it's important though to get that formal training to at least some extent, know the formulas, read the textbook. Even if you're not going to get a degree, read the textbook. Like my roommate in college was a construction management, I think that's engineer, right? School of Engineering. So
yeah,
I'd read his textbooks. Yeah, I'd read his textbooks, and I really appreciate getting that real knowledge. So, and I kind of got a little distracted from your question, but I just like building things, and I'm trying to take people from that DIY space that just, playing with Legos without instructions to let's go make something that we can send out to a factory and they can manufacture it. There's no like right angle corners where it needs to be CNC'd. You can pull it out of a mold, tapered edges. And so I think that's kind of my specialty is I'm not quite too much on the DIY side, not on the full on, formal engineer side, but I'm really kind of like bridging the gap in the middle.
Yeah. Tell us a little bit about that. How did you see the need for bridging that gap, and what are some of the things that you've done to help people bridge that gap?
I think it's our supply chain. There is this guy on YouTube called Destin from Smarter Every Day, and he tried to make a simple product here in America using all American components. And like he's a big deal. If he couldn't do it, he's one of those realer engineers. He knows what he's talking about. He has a team behind him, and still they couldn't do it. They couldn't find the supply chain parts that they needed. It takes 9 items. They're making a grill scraper, some real simple product, maybe 1 injection molded piece. But if he couldn't do it, it just kind of broke something inside me. And if we don't have people who know how to do something from the bottom up, most of the supply chain isn't complicated. Some small group of people investing in one expensive machine and just keeping it productive 24 hours a day. Whatever that thing is you do, you specialize, you get a little bit better at it, and just crank them out. I mean, there's whole people who just make screws, like just screws. That's it. So that's what what kind of got me going is how we can actually do that if we don't know how to build those machines. If you want to build anything, you're going to buy a machine to do it or make one, but you're probably going to get a mold from China. You're going to get your PCBs from China. You're going to get your everything. I mean, maybe some really good stuff from Japan. Those linear slide rails and stuff like that, linear guide rails. But I just don't think we have enough stupid basic machines. I mean, they don't need to be complex. They just need to exist and people need to make them. So that's what I want to teach people how to do is make those stupid basic things, but make it in a real way where you can make a real machine, sell to people, and kind of start making stuff. I don't care about making big things in America. Like, that's for someone else. I want to make the screws and the bolts and just get it going.
The basics, yeah.
Yeah.
Tell us a little bit about your YouTube channel, and why you started it and the impact you hope it's going to have.
Oh, geez. Well, I didn't expect it to be successfour I mean,
it's fairly new, right? Like a few months or something?
2 months old. Yeah, 2 months old. I've released four long form videos, about once every 2 weeks. And I have my 5th one out, coming soon. First sponsored video. Big exciting deal. But it's all about how to get into electronics, how to make real things. Like, everyone's going to say, go to school for that. Like, just become an electrical engineer. That's all you have to do is just spend $80,000, 4 or 5 years, go get a job after that. And I'm like, nope, like, spend $50, get a starter kit on Amazon, soldering iron. Everyone will tell you, get that $200 soldering iron station. And I'm like, the one that's $10 on Amazon sold 5,000 units last month and has a 4.6 star review. I'm pretty sure it works. So, that's I guess what I'm trying to do with this is there's all these people who want to make things. They want to do things, but they're nervous. Like, they've seen other videos. They know all the basics. And it reminds me, like, at a school dance, like, the boys and girls, they want to dance, but they're nervous. Or, everyone's sitting on the side of the pool. Everyone's just sitting there. They want to go in the pool, and I just go and push them in. I'm just trying to push people in the pool. So I guess I just want people to get started. Just get doing it. Like, the hardest part is starting. Like, in yoga, they say the hardest part is getting to the mat, just showing up. And I think it's the same thing with electronics, learning. And so I want to show people how easy it is. show them what they need to do it, but kind of hide some of the scary stuff and more just kind of push them in the pool, get them going.
Yeah, that's awesome. So you mentioned you didn't expect the YouTube channel to be successful. What were you expecting, and what happened?
Well, I got like 50 views on my first video in the first day, and that was great. Like I was doing good. I spent 10 hours of my time making this video. That's a decent amount of time, and video's like 5 minutes long, and so 5 times 50, that's 250, that's 4 hours. Like in one day, half of the amount of time I put in that video was seen by other people. I'm used to talking on the phone or seeing someone one-on-one, and so working hard and on the very first day, 50% of my time was kind of like day 2, I kind of broke even. I got 100 people to watch my video, and then it was like 300 the next day, and then like 500, and then 1,000. And I'm from a town of like 3,000 people. Yeah. Like it's weird to kind of think like, how do you think in terms of people, like stadiums? Like it's not like you're in the center of a stadium giving a speech or anything, but like, how do you quantify 3,000 people watching? I was gonna say my stupid face or whatever, but it's just awkward. It's weird. I think nothing kind of prepared me for my second video getting over 100,000 views in the first month. So,
wild.
50 views, 50 views in the first day. That's on the first video. That's something. But then 100,000 people in a month, and you're just like, why are they even watching me? What's so entertaining, or like what's worth it? And so now I'm getting 30, 40, 50,000 views on these videos, and I'm only 2 months in, and they get more every day because I guess they're called evergreen content. Like, how to start electronics. What do you buy? That's going to be popular for the next 10 years. I mean, not popular, but relevant for 10 years and a lot of these other things. So I just didn't expect people would like it. I thought it'd be like 100 views on a video. I'd be like, yay for me.
So this was just a labor of love for you, right? When you started, you just thought, it'd be fun to do this. I'm just going to do it because I want to do it.
I wanted to teach people how to make things, to build the stupid machines for the supply chain and all that stuff. Like that's my grandiose thing. Like, of course, I'm never saying that in the YouTube videos. I'm not saying like, I want you to go build a machine to save America. Like, I'm not saying that at all. But I figure you inspire people. Like, I was inspired by people on YouTube to get into electronics. I learned by watching people on YouTube. And so I figured I could just get that much more people started. Maybe if I was a teacher, how many students would I have in a year? 150, 300, and now 100,000 people watched my dumb face in this second video. So it's just those numbers kind of made it go from maybe I can kind of like teach someone like maybe 100 people something to, geez, everyone's really looking forward to that next video. Huh?
No pressure.
Nope. Oh God. And then having a sponsored video, and now there's money on the line and contracts. And, the weird thing was you make one video on the topic and everyone wants to send you a $50 thing to review in a video. And so it's just like, my spam folder is just like, what do you like this free product? And it's just, I don't know. Like I work a full real job. Like, I make real things for a living. So this is just a labor of love. I wake up in the morning and you're like, how much time can I actually dedicate to not my job today?
Yeah, right. How has the response been from the community? I mean, obviously a lot of people are watching your videos, but what kind of comments or feedback have you received?
That's my favorite part of this. So amazing feedback. There's jerks on the internet. I was told of course, whoever you are, even if you're a reasonable person, like some people just won't like you, right? Like no matter who you are, you're like, you'll open your mouth and like, I instantly don't like you. And you're just like, what am I supposed to do with that? So there's that percentage of people. And then there's those people who are just jerks. And so I thought it'd be like 20, 30% comments like, you're ugly, you know, or why do you have that thing? What's on that shelf back there? You need to clean up your room. Or like, you know, I thought it'd be stupid comments, but instead everyone's just like, thank you so much for that video. It's exactly what I was looking for. And I was like, what was it you're looking for? Like specifically, I'm not sure. or thank you so much. The weirdest ones for me are like, I'm a mechatronics student. I'm in my 3rd year and I've never done anything with electronics. And I'm like, I got a finance degree and I played with electronics. So I'm just like, that's kind of like, that's like the whole, I want to be on the side of the pool, just like pushing these kids in, like, go play with electronics, go buy Arduino kits, go do something. Just,
that's awesome.
Yeah. It's weird how positive the feedback is. I'd say it's 97% positive. Wow. And what I love is all the old engineers, like so many retired people are like, you know, I used to go and work on this kind of machine and doing this. And then they're like, do you mind if I just email you a bunch of questions? So like I'm building a CNC machine in my garage. So that way I can start teaching people how to make molds. Wow. Like I've never done injection molding myself. Like at work, we've had molds made, but I've been practicing, by 3D printing parts, sanding them, cleaning them up, airbrushing them, putting them in silicone molds, casting epoxy and cement and all sorts of things like that. But I want to get to injection molding because if you want to make a product every 20 seconds, like lights out production, just 24 hours a day, that's the way to do it. So, I have a lifetime experience of programming. Programming firmware is actually my specialty. So, automating a CNC, like I automate houses for a living. I automate businesses. I control all the electricity that's running in a business or a house and kind of make it dance and save you money. And so I can make some motors go to some predefined coordinates and like spin at this rate. And like, I'm not trying to trivialize CNC, but I know my stuff and I'm going to screw up. I don't know what I don't know. So all these people in these comments are like, I used to be a CNC operator at this company, and then I started doing this. And nowadays, I do injection molding in my basement for fun. And it's like, so how many questions can I ask you?
I've seen some injection mold machines that are pretty inexpensive, like desktop injection mold machine for like, you know, $3,000 or something like that. And you can 3D print the molds. I mean, they're not going to last, obviously, as long as a steel mold
50 runs or
tool is going to
shots.
last, but yeah, right. Exactly. So you're building a CNC machine in your garage right now. Tell me more about that, because that sounds like a daunting project for anyone, but you're just taking it on.
I'm overconfident in the best and worst ways. So, I have my particular makes and models of like the best people in the world, like DMG Mori. There's some amazing companies who have made amazing machines. And it turns out they all make YouTube videos and show their latest models. They go in and like, they'll do a 3D exploded view and show where all the rails are, where all the mounting points are. And I'm just like, I'm going to rip off part of that one. And I like the base on that one. And this one's really good at this stuff. And so I'm just going through, ripping off the best specs and designs. And I know I'm going to screw up, so I'm making a first basic one that's going to work okay. But kind of the trick to a CNC machine is you need a CNC machine to make a CNC machine. So I'm making a first kind of basic one, giving myself about a $2,000 budget. And the only reason why I'm kind of doing that is experience. Or I could send these off to like Send or have some other local machine shop make them for me. Or I could spend $2,000 in a month, blood, sweat, and probably literal tears, and get some experience. And then that second machine, I'm sure I'll go back in my CAD program, run optimizations, and at that point I'll be like, I really get why you have to do a vibration analysis. So then I'll have to go and try to use my YouTube thing, be like, hi, expensive company that makes really good simulation software. Can I please have your stuff to run? That's the whole plan.
In all seriousness, remind me after we finish this recording, and I might be able to connect you with one of those companies who I know is looking for opportunities to do co-marketing because we've done some with them, and they might be open to some kind of collaboration with you.
All right. If you know anyone who also does like motors, like electromagnetic. All right. So you know how light's just like electromagnetic? It's like, why is electricity and magnets related? Turns out like motors are basically just electricity turned into magnets, and it's just this crazy weird physics phenomena. But if you can go in 3D model, like make a 3D model of it, it can tell you basically exactly how it's going to work. And then you just run these little optimization programs. And so that's all right. I do computer science for a living. I write software, I write firmware, I do optimization. That's like my boring day job. And so with this whole YouTube thing, I'm excited where I can make a CNC workbench and then I can make a video about it, and that video will probably pay for the bench or the whole machine. And then I want to make some motors. So then I can reach out and ask some people for some simulation stuff. And then you can go and reach out to someone and saying, hi, I need this other thing. And so as long as you do it in like a genuine way, I think it's just, this is the great thing about being a YouTuber I never expected, is that people want to go and say, look at our awesome simulation software, look at our awesome components or our awesome bottle of epoxy resin. And you could buy it for $200 for all these things, or just say, I'd like to please use it in a video. I'll mention your company. And I don't know. It's so weird. It's all communication. It's at the center of it. It's all communicating with companies, with sponsors, with the viewers in the comments, making the videos. That's what I'm just realizing is this podcast, everything in this new YouTube world. It's all about communication through so many mediums, so many forms, with so many different types of people.
Everything we do with and through people, and communication is the mechanism by which we collaborate with people who work together. Yeah.
Yeah. And I'm sorry if I get a little rambly there. It's just, it's so weird, to kind of talk meta YouTube. Again, I'm 2 months in. It's weird.
Well, congratulations on all the success you've already had and all the success I'm sure you're going to continue having in the future. I'm excited to continue watching your journey there.
I'm excited for PDX. All right. So the Product Development Expo, really, like I said, I'm trying to push people in the pool to go get hands-on experience. This is the thing I'm most excited about. Like, I know it's your thing, but like I wanted to go and build the CNC machine. I need to go learn how to build robots to go and place a little block of something on the CNC machine. I've been working with stepper motors and all the electronics for years. I have no qualms about doing that. But where do I learn how to program this like a pro? So this thing like doesn't actually turn around and hit me in the face when I'm trying to program it. I'm sure someone will say, you always disable all the motors before you do X, Y, and Z. PDX is where I'm going to learn in a session, but then the surface modeling, all this 3D printing, So, and it's just, I think PDX is the future. I think stuff like that, whether it's your event or more maker spaces where people can get hands-on training, because if you compare these people who do it for a living, these people who make the CAD software, who make the machines, who make the tools and all that stuff, I think that's the next form of communication, is kind of breaking down that bridge of, we don't have to advertise in a magazine anymore. We don't have to go and do ads on some random website or whatever. I think there's some next generation thing of kind of sponsors without being too sponsory, if that makes sense.
Yeah. Well, thank you for the plug for PDX. And just to be clear, I did not ask James to say that. That was all James, but I appreciate it. We're also obviously very excited for PDX. One of the things that I think is going to be super useful for folks like you, for all the attendees who are there, is not just the formal training sessions, right, of which there are one every hour for 6 hours each day, and it's 2 days. So you could conceivably hit up 12 different training sessions. But outside of those formal training sessions, we have open office hours. And so you can approach any of these. We have 35 different training partners who are there, all industry experts in one area or another. And all the attendees can approach these industry experts in real time at the event and say, I have this problem at work that I'm not sure how to solve. You're an expert in this area. How would you solve it? And you can get answers right there on the spot from experts.
And I don't know if this is kind of more the Dale Carnegie how to win friends and influence people type thing. I'm looking for the networking, like meeting people, being like, hi, you're a cool person. I'm a cool person. Let's exchange emails. And now you have a great contact. So it's meeting the individual people who go like, hi, I'm also an attendee. What are you here for? This and this. Me too. So I'm not trying to like go to there to make friends, but I'm looking forward to it.
Yeah, it's gonna be really fun. As you have, I mean, throughout your life, right, learn how to build things, to program. You're getting into the mechanical side of things as well. What is a mindset shift that you think needs to occur for people to go from, tinkering, doing things in their garage, DIY, to actually developing something that can be mass produced? What are some of the mindset shifts that you think are important?
Well, I think there's a difference between making something and mass producing something. I would almost say that, I don't want to say that they're two different skills, but for example, you can make a product, but can you sell it? Like that's someone else's game is to be good at selling. Like I might be really good at prototyping. I'm not good at okay, but I'm not great at the factory where they're saying, if you did this little thing, it would shave off 30 seconds a unit, which is, I mean, it's small, but we're doing it on every single unit. And so that design for manufacturing, I think you need to realize, and the average person needs to realize who's getting into this, that there's a difference between having a 3D printer and having something that can be manufactured 10,000 units a month. It's for me, it's all about life is super dang complex. Like engineering is hard, making products is hard because the problems you run into aren't going to probably be the problems you're expecting to run into, or at least whatever it is, there's going to be delays, such as we got this great product released, it was sent out to the factory. They're manufacturing it. It's going well. And they go to program it and they can't program a single one. And I'm like, you literally have the same laptop I do. You have the same thing here, the same thing there. Everything's the same. Gosh. I mean, literally, it's just a USB cable it's literally just a USB cable that's different. That's the only thing between our two setups, but it's a USB cable, right? No, our manufacturing was down for 2 weeks because they tried sourcing cables in Asia and they couldn't find a good one. We had to ship one from the US all the way into Asia to our factory. They plugged it in and it worked perfectly. Oh my goodness. Would you have guessed a USB cable would tank your production for 2 weeks? And you go, it's like, I'm going to make an episode on why I have a love-hate relationship with USB cables. So that's something that's a problem.
I wanted to ask you about that. How do you decide what to make videos about?
Well, first you make a list of every good, bad idea you have. And then you start thinking, what am I actually trying to do at this point in time? Like my first video was, how do I get people into electronics? Like, how do you go from 0 to 1? So I made a video eventually about what you need to buy to start electronics, but I phrased it kind of like how to start electronics for $25 or $50 or $100. But then that YouTube title and thumbnail was a horrible combination and didn't get very many clicks. Well, I mean, it got 50 on the first day and all that, but just FYI, I changed the title to like how to start electronics and change the thumbnail, and all of a sudden it got like double the views the next day. But so the first video, they gotta start electronics. The second video is, well, gosh, they're just going to read the tutorials and just know how to do 10 things and that's it. So I have to teach them kind of how to not be dumb about doing this, because there's so many bad ways to learn electronics. And I'm not insulting the viewer. It's like you're given 15 little lessons and they say how to do this thing, how to do that thing, how to do that thing. What they never teach you is how to make an actual project. They never say, use this and combine it with this and mix in some random other part to do some logic between them. They never say, work on your own, try something yourself. I mean, they might suggest if you use 2 resistors instead of 1, what do you think will happen? But it's not like, here's your homework. Like a good engineering professor will say, here's what we learned today. I want to challenge you to do X, Y, and Z, and give me your thoughts or your possible solution for this problem. And maybe they're a jerk and there is no solution, and they really just wanted you to kind of like figure out that some things are just so hard and so insurmountable. You got to be like, you actually can't do it. So I don't know. So my second video is all about how to think like an engineer, how to kind of just like bust out that mold of like being a student, reading a book, and just how to make anything. So that's kind of what I'm doing, is I'm just trying to figure out, I made a video about this and now those people kind of get to here. I made this other video and now these people are here. And so I'm making a video about how to find awesome chips, because if you buy stuff on Amazon, it's like 5 years old, but they make new chips every single day. So how to find those new chips on those big companies. But now you need to know, how do you actually make a circuit board with those chips? So now that's what this video is about. So it's all like this arc, this series, this whole meta thing of, when I listen to the comments, when I talk with these viewers, whether it's in emails or just 10 comments back and forth, replying and going through them, where are they? What kind of people am I bringing in, and what do I need to do to kind of get them to that next step?
I think this is so valuable, right? Your channel and other channels out there like this who are teaching people the practical ways of how to do these things, whether it's engineering or law or dentistry or whatever, right? Like teaching people the actual practical things, how to do something. When I was in college, I didn't love college, to be honest. I was very excited to be done with the academic part of engineering and just get into the actual engineering. And the primary reason for that was there wasn't a lot of doing in college, right? There were labs here and there where there was some doing, but it was mostly learning about doing, not actual doing. And I have a motto. I say that doing is better than learning about doing. And so college was all about the learning about doing, but then you graduate and get into, the actual role and okay, now we're cooking with butter here. Now we're actually doing things. But your channel and channels like that, they're, I think, so valuable because they actually show people how to do these things.
Yeah. I think I'm also kind of a product of my environment, in the way that when I was getting my finance degree, just Northern Arizona University, I figured it was either between an engineering degree at Arizona State University, mechanical engineering, or a finance degree. And well, if I want to have my own business and work for myself, I need to know the money side. I can always figure out the engineering side later. Well, here I am, kind of figuring out the engineering side, but I know the money side. But still, it's just super bored. I mean, you take science courses and you just read about it in a textbook. So my job in college, because my parents said, you have to get a job. So I said, all right. I applied for 3 months in a college town with more college kids than other people. No one was hiring. So she said, fine, just go volunteer someplace. So I volunteered at the coolest place in town, Lowell Observatory, that old telescope observatory on the hill. Yeah. And so my job was to be a tour guide. And when you have all these awesome telescopes, all this great history, and then you have all these science majors, not trying to diss my old colleagues. There's good people and bad people who give tours. The bad people are the people who say to a 4-year-old, a black hole is a blah, blah, blah. And they go, but what's that? And you go, science, 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 jargon, jargon, jargon. And for me, I'm like, you want to see something cool in a telescope? You want to see something that looks like spray paint in the sky? Let's go look at a cluster. You want to go move the telescope? Like, I'm not allowed to touch it. You're like, why not? Like, here, come push on the telescope. And they go, oh, that's so easy to move. And you're like, it's because it's balanced with weight. And you're kind of subtly explaining these physics and these big concepts. Just like, you're not trying to bore a 5-year-old. And you get lots of kids up there, but you also have to talk to their parents. And so I think being a tour guide, just being sick of school, wanting to go play with a telescope, by the way, if anyone is traveling through Flagstaff, I'd recommend checking it out. And the best thing is, if you go there in the winter time, this is where I think I really got my whole persona, is in the winter time. You have this big telescope and no one in line. Like, I'm being paid here to man a telescope and show you Saturn. We're looking at Saturn tonight because that's what's in the sky. Normally, you have a line of 300 and you say, that's Saturn. All right, next person. That's Saturn. Hey, want to see some rings? That's Saturn. You just don't have time. But in the wintertime, you have this amazing telescope in like one family, and you're like, what do you guys want to see? What interests you? And you just start pointing around, and then you start going and taking out star maps and asking their parents, what sort of fairy tales or lore about the sky do you remember? And we'll go and we'll find, it turns out that's that star over there. You want to go look at that? Sure. All right, kids. Hey, do you think you can point the telescope over there? Like, don't worry. You're not going to hurt anything. Just move the telescope. So I think that's really what I'm bringing to electronics is, don't worry. Like, your house is not going to burn down. Go spend $50. Don't spend $500. If you spend more than $100, you're doing it wrong. You're spending too much money too soon. And so I'm just trying to get people in it, show them, hey, look, want to see some spray paint in the sky? Let's go look at a cluster. That version of electronics. It's fun. It's interesting. It gets them engaged. Because how else are you going to get someone engaged? I mean, you kind of have to meet them where they are. So that's where I think I got a lot of my zest or my joie de vivre or, style or whatever you want to call it.
Well, this is why I think your YouTube channel is gaining so much popularity so quickly. You know how to communicate with people, right? I loved your science, blah, blah, blah. That's not what you're doing, right? You're using normal words that people understand and communicating this stuff in a very approachable, practical way. So thinking back over these projects that you've done, and it doesn't need to be just out of the projects you have on your YouTube channel, even going back further, what's one of the most challenging projects that you've taken on and accomplished?
Oh, you had to say accomplished. Because there's a lot of challenging failures.
We can define accomplished loosely.
Yeah. Well, I think the most satisfying thing that I've done, the most challenging thing was, so I got a finance degree. I was not a programmer. But I'm a nerd, right? Like, I love science. I was working at the Observatory. I had this idea for a new type of solar optics system, and I wanted to see if it could be done. I mean, I thought it could work. So I hired someone on like Fiverr, like whatever Fiverr was called 15 years ago, like Upwork or there's some random freelancer site, and I spent $200 of my hard-earned money, making $8 an hour at the Observatory. So that's like 50 hours of work. And what I got back was just abysmal. It was like, I spent that much money for you to make me a little scientific simulation thing. I paid someone else to program it, and it came back so horribly. I was like, you know what? I'm going to see how I can program this better. So I tried to learn how to program, and it didn't go well. It took like 5 years, and I ended up traveling around Eastern Europe because I didn't have a lot of money. So I was either going to go and live in Mexico and learn how to program, or live in Eastern Europe and learn how to program. And Mexico was really dicey.
Hold on. You were going to go live in a different part of the world because the cost of living was low enough that it would allow you to live and learn how to program. Is that accurate?
Yeah.
Dang, man, that is inspiring right there. That's dedication.
Yeah. So I know all the best park benches in Poland and Ukraine and their big cities. Man, I had so many good times. I'd bring my backpack with about 8 laptop batteries. And because this is like it's back when the laptop battery would last like an hour. So you want a full work day? 8 batteries in the backpack. And
that's got to be one of the best quotes I've heard on the podcast so far. I know all the best park benches in Poland and Ukraine.
Well, where else are you going to... I mean, I could be boring, go work in a building or study in a building, but I'd download free books and free lectures. And this was like when OpenCourseWare and other Stanford, MIT, Harvard, all of them were starting to put out their courses on YouTube and stuff like that. So I would just download whatever I could. I'd find some old textbook that someone scanned into a PDF from 10 years ago. Maybe I shouldn't say that, but get that knowledge wherever you can, right? So, I was just traveling around, and eventually I learned enough to where felt comfortable learning about AI. And so I was at that point I was in Croatia in a penthouse suite overlooking this great bay, because it was the middle of the winter time, and there was no tourists there. And I'm like, a penthouse suite, that sounds fun. Like, and then I realized you had to pay for the heating. There was bolt holes in the wall, so like the ventilation was just constant. You'd go to take a bath, and then you'd run the washing machine or the clothes washer, and you'd get this weird taste in your mouth. It's because the electricity was running through the pipes and slowly electrocuting you. So it wasn't quite the deal and bargain I thought it was, but it did give me 3 months to read chapter 1 to chapter 15 or whatever of this AI textbook. And every chapter I would try to apply to my scientific simulation, because at this point I learned how to program. I made my simulation. I was having to go and use generative design to try all these designs and optimizations. And every new chapter, you learn about a new different type of AI thing. And it's never large language models. It's about clustering, how to search through all these possibilities to find a good outcome. But yeah, so that's where I learned how to program, is traveling around. And I got to the end. I got this amazing simulation going, and the results weren't great. So, so I spent 5 years or 6 years or probably maybe 8 at that point. I know how to program amazingly now. But that specific solar optics thing, it just, to put it bluntly, if it was this big, it'd work. But it was supposed to be like, infinitely small, like it's super small optics, and just, at that point, you're dealing with more waves, and instead of light being like a particle, it's more of a wave, and that's quantum stuff way over my head. I didn't know that. So that was the hardest thing I've ever done work-wise. It ended up in a failure, but I know how to program. I've been writing firmware for electronics for years. That's kind of how I got to where I am today.
Yeah, I mean, maybe the end result of that specific intention was not a success, but the skills you picked up along the way were hugely successful and continue to serve you.
My dad, he was so wise, and it was so annoying when he'd say this. I helped my dad. I wrote some great software for his company. So he's in a sales industry, and I wrote some great stuff to help his salespeople talk to his quote people better and exchange information and help find how they can make a lot more profit with some existing stuff they already had. And my dad said, I know you want to sell this to a lot of other companies, but even if it doesn't work out, you still got some great experience learning how to make a web page, how to go and make a cloud application and a server and all that. I'm like, Dad, I don't want to do that. I want to make money. I want this to be successful. and it turns out, due to a lawsuit thing, that's another thing I learned is, when a lawyer says stop doing something, you just got to stop. So. Oh,
there sounds like a fascinating story behind that.
Oh yeah. It's nothing you can say out loud on a podcast, but spent a lot of time and my dad a lot of good money on that, and had to immediately cease and desist operating it. But at that point, I learned how to build a cloud platform. The next step was learn how to build an app, and at that point, it's soup to nuts. You know how to make your circuit board, design the chips, program the chips, have it talk to other chips using wires or talk Wi-Fi, go up to the cloud, store in the cloud, make an app, make a website, send it to Alexa, and say, hi, Alexa, how much power is my house using? Or, whatever. And it's just, that's the fun world. So yeah, I could be working for a big corporation, making a lot more money, but I'm having a lot more fun doing this.
That's important. You got to love what you're doing, right? I mean, if we spend so much of our lives working, if we're not enjoying the work, then it's time to make a change. Money isn't everything. It's up there with air and water, but it's not everything.
Exactly.
Okay. Let's see. I had a question.
Do you mind if I ask you a question about your company?
Go for it. Yeah.
So what do you guys look for when you have young engineers? Such as, I have so many young engineers watching my channel, and there was someone you had on your podcast maybe 5-10 episodes ago, and they're all about recruiting people and hiring engineers. And one of the things I really took away is they said, if you're not sure what the question is or how to answer it, don't give some 30-minute long answer. Give maybe some concise thing and say, is that what you meant? Or can you clarify? Is this So little things like that. What's kind of like those hidden gems like that young engineers would want to know, like if I know this skill or if I act like this in this interview, what's kind of the best ways to kind of get these people watching my YouTube channel to being where you would actually hire them type thing?
There are a couple of things that come to mind. The first is an indication that they actually really do love engineering, right? And that typically doesn't come from a resume or grades at college, right? That comes from, growing up, I rebuilt this car engine with my dad, and it was like one of the best experiences I ever had, right? So when I see new engineers that actually have some hands-on experience, not necessarily with, developing a new medical device, but building something, right?
They got their hands dirty somehow.
They got their hands dirty, exactly, right. That's a big one for sure. And then the other thing is just the willingness to put in the time. There was an aspiring engineer. He wasn't formally a degreed engineer, but he wanted to become an engineer, and he was going to school for it as well. He asked me one time, how do I accelerate my progress in becoming an engineer, right? And I didn't have a great answer for him at the time, but I remembered that question, and I've thought about it over the years. And I think one of the answers is you just have to spend more time doing it. Like there's that whole thing about the 10,000 hours, right? You do something for 10,000 hours and you're an expert at it. I don't know if that's true. In fact, I've heard it's apocryphal, but there's probably some element of truth to it. And for sure, I know that the things I've gotten good at because I've spent extra time doing them. I haven't stopped, 40 hours. I've hit my 40-hour quota for the work week. I'm done. No, that's not how I operate it. It hasn't been for a long, long time. And I think the engineers out there who come into it being willing, there's of course a work-life balance that you need to respect, but you don't have to just cut yourself at 40 hours and say, I'm done. No more work, right? There was a young engineer, a degreed engineer this time, who joined our company. And when he joined, he said, I could see myself happily spending a lot of overtime just doing the job here because this is what I love to do. And I was like, bing. Okay. I mean, the fact that I'm getting some free labor, hey, I'm not going to complain about that. But just the mindset of I love doing this so much that I would happily spend more than the typical 40-hour work week doing it. That's a big deal.
Oh yeah, I completely agree. It sounds like you and I are in agreement that you have to first like what you're doing. Because if you don't like what you're doing, you're not going to be good at it. And now that you like what you're doing, you're going to put in not just 40 hours, a heck of a lot more. And then what I think is important is kind of like you're saying, they're willing to go above and beyond, not just that 40 hours. Like anyone can show up and just occupy a space. I think it's like that curiosity to say is it okay if I bring in my personal project on the weekend? It's basically very similar to what we're doing. Yes. Is it okay if I use your expensive machine and just do this one little thingy? If you got that in you, you're welcome in.
Absolutely. And it's those people who want to and do spend all that extra time that really become great at what they're doing.
So I'm not trying to brag about me or whatever, but I was talking with one of the guys, one of the retired guys I've met on YouTube doing this channel, and he's doing this lot of 3D printing stuff, but it's 3D printing for enclosures for circuit boards. So it's like this way that you can flexibly put in any circuit board, and it can just kind of fit into a control panel. So instead of having to design a big control panel custom every time, it's this modular control panel. And so this weekend, I'm dang tired. It's Friday, long week. Just had my first shower in 3 days. I was installing off-grid solar for a family friend in Flagstaff, way out in the boonies. And so I just want to kick, lay back, put my feet up, have an ice cold beer. But I have a list of 3D printing objects I want to get queued up so I can get going this weekend, so I can give him feedback so we can start working on the next iteration of this. And then I got all these other things like the molding and casting. I got a bunch of stuff I got to sand. It's finally starting to be sanding weather. Most people have nice outdoor tasks, I like to go outside and wet sand objects. So, so I think it's just, you need to, when you're exhausted at the end of your work week, if you have a passion for something, that's probably what you should be doing. At least that's me. You know, if you still want to do it, even when you're tired.
Yeah. Yep. Absolutely. All right, James, let me ask you one more question and then we'll wrap things up here. So your first video, right, was how to start electronics, how to get started in electronics. Most of the listeners on the Being an Engineer podcast are more in the mechanical realm than the electrical realm, and not all of us are Sparky. We don't all know about electronics, myself definitely included. In fact, my team won't allow me.
I've heard you in your podcast.
I'm horrible. I have this mental block. It does not compute. One of these days, I really would like to sit down and learn electronics, but right now it's not a priority for me. Anyway, I assume that there are a lot of people listening to this who are mechanical engineers, manufacturing engineers, who have maybe dabbled here and there, but don't really know electronics very well. What are some pieces of advice, some pointers that you can give for, like, how do you get started? What's a good practical way for someone who has, you know, some engineering background experience already to get started in electronics?
All right. So first thing, take a breath and realize it's not that complicated. So what all your worries, like, oh no, it's going to catch on fire. It's not going to catch on fire. It's not going to explode. You know, no one's going to die. Worst case, a capacitor goes poof and the magic smoke escapes and never goes back in. So whatever you do, don't worry about it. Just don't touch grid power. Don't mess with high voltage. Everything else is completely fine. So go buy a starter kit on Amazon if you want starter. All right. So explain the world of electronics in a little microcosm. There's these little microchips, just like in your computer, like your what would it be? CPU. So you have these little logic chips, they call them microcontrollers. Instead of a CPU, they're called an MCU, a microcontroller, instead of a central processor unit or whatever. So you have your brains, and all you have to do is connect whatever else you want to it. If you want to go and turn on a light, you can simply program this little brains unit to go and just turn on a little imagine they have like an extension cord. They can basically turn on and off all these little tiny wires around the chip. So you can program it to say, turn this one wire on and then turn it off. Do that every 1 second. And now you're blinking an LED. I mean, that's boring, right? So let's go and put on a relay or a MOSFET or a contact or some big thing to turn on huge amounts of power. That same blinking a light, you're now turning on and off a 10,000 watt motor. You know, that's electronics, right? I mean, what else do you want? Like, as an engineer, you want to control stuff? Cool. Don't just turn it on for a second and turn it off. Turn it on for like 60 thousandths of a second, and then turn it on for 40 thousandths of a second. Point being, you're now turning it on with a 60-40 ratio instead of a 50-50 ratio. If you want to throttle, you now do a 90-10 ratio or a 99-1 ratio. So whatever it is in electronics, like, stop thinking it's complicated. Like, you just program a little tiny black box that just works with basic code, and it can just interact with all these physical things around them. You can get sensors for anything. I'm looking for a carbon monoxide sensor because that nice lady, our family friend up in Flagstaff in the off-grid cabin, she goes, well, can't I just heat my cabin with the stove? And I go, I kind of want to show you with a calibrated carbon monoxide sensor when it's okay to, like, heat your coffee. And if you leave on all 4 burners, you see that line for that carbon monoxide reading just go way up. So that's what I love about electronics is you just need to find a project. I don't care what it is. Find a stupid basic project. Go buy a starter kit, which has a little microcontroller, a little logic thing, 20, 30 sensors, wires, a little power supply. It'll come with a little guide saying, here's how to use every one of these little components, but don't be boring. Don't just go and, like, say, look, I turned on an LED, or I made a servo go and move 90 degrees. Like, that's all boring. What you need is a project saying, I want to do X, Y, and Z. I need a LED so I know it's plugged in. I need a second LED to know, is it in cycle A or is it in cycle B? I need a motor so that way when the sensor detects this, I turn on the motor until the sensor now detects something else and I turn off the motor. Like, you just got to find some stupid basic thing go and buy some stuff and just get your hands dirty. And yeah, you're going to fail a bunch of times. And the only way you can screw stuff up is connecting power and ground. Basically short circuit. Like, other than that, you're pretty much fine.
That's awesome. Great advice. Find a project that you want to do, something real, and then use that as an opportunity to learn all the things, the technical things that you need. I want you to come. So you're coming to PDX already. I want you to come visit our booth, because we are showing off our Easy Motion product, and it's a super simple way for controlling motors and pneumatics and sensors that doesn't require any programming. Now, you of course know how to do the actual coding behind the scenes. You don't need Easy Motion, but I want to get your feedback, your take on it, because it's just this it allows people like me who don't know any programming to create automation and motion and process signals.
You're telling me
like that.
I give a grandma a remote control to control her house. Like, trust me, like I have an easy button. Like, you want to just like press one button and do zero configuration or setup. Like, I get people like that exist. They want to plug in the product and have their house save money. Other people want to go and control everything and automate it. And so, yeah, you have to meet them where they are. You have to give them the one easy button. You have to give them the super simple control algorithms. That way you can say, I want this thing to turn on this, and it's above higher priority than this thing, except if it's above 85 degrees outside, then this thing is now the top priority. Like, you have to make all right. The real example is my business partner's wife. If she can't use it, she's not tech savvy. Like, she has an iPhone. She knows her basic stuff, but she does not know controls automation.
Most people don't. Yeah.
Yeah. And so you have to find some way to get these crazy complex algorithms like distilled into the like, I'm too hot, I'm annoyed, I want to press 2 buttons max and you need to fix everything. So I'm excited to see your motion controls and also, don't you do like repeatable test jigs?
Yeah, like cycle test fixtures. And yeah, exactly. That's what Easy Motion is. That's one of the primary use cases, in fact.
So how many times do you think I can press a random button I buy from like just a random distributor in Asia? So like, we're talking like, it's like the Walmart of where you buy buttons and capacitors and LEDs and all these stuff. I just grab a random one, throw it on my board, maybe put a little cap on there. What's going to fail? How many times can it reasonably be pressed? Tell me about that. I'm curious.
So that, again, we did not plan this. I did not ask James to ask me this question.
Sorry. I'm bad about sponsored stuff or whatever.
It's okay. No, it's totally fine. I just didn't want people listening to this to be like, wow, how much did Aaron pay James to ask that question? Quick answer. That's exactly one of the use cases for Easy Motion is it's so easy to rig up. You could just do a little 3D printed fixture to hold the button in place. And then the programming in Easy Motion, it's all visual drag and drop logic blocks. So like literally there's a block that you can drag onto the programming interface that says extend cylinder or retract cylinder or move motor to this position or wait 2 seconds.
What about like smashing force?
Yeah,
does it have
all
like
of the
force
above.
Feedback?
Awesome. Yes. Yep. There's analog feedback. So you can put a force sensor in there, a load cell, and say, when this load cell goes above 2 pounds, move this air cylinder, right? And it's all these super simple logic blocks that literally anyone can program. I taught my 9-year-old daughter, there's a video of this online. I taught my 9-year-old daughter how to program with Easy Motion. And in half an hour, she was up and running, making her own industrial automation. It was pretty cool.
Awesome. So what normally breaks with the button? Is it like, if it's like a keyboard key, is it like the key cap gets like crooked and pressed wrong? Or does the button get like stuck down and due to some stickiness factor on the bottom? Like, what happens?
I don't know. I don't have the answer for that. I'm not an expert on what fails in electronics button, but that's something that you'd have to test, right?
All right. I want to get one of your jigs and I'll test it.
Cool. Yeah.
Cool. All right.
Well, James, thank you so much for being a guest today. This is so much fun getting to know you. I've been looking forward to this episode ever since we connected several weeks back, and super excited to meet you in person at PDX as well. Tell us, before we sign off here, where can people find you, and what's your YouTube channel called, and any other social platforms that you want to share?
Well, I'm just a regular nerdy engineer by trade, but I started doing YouTube. And so you can find me on FluxBench, FLUX. So Flux is a thing that when you're soldering, it's kind of like welding, how they have those gases for the shielding to make sure it doesn't oxidize and you get a good weld. Flux is an electronics equivalent. You put a little bit of flux on the thing you're about to go and solder, and when you solder with flux, everything just works so much better. So FluxBench it is on YouTube, and just click on my channel. You can click about and then find my email, or really leave me a comment on any one of my videos. I'm nerdy, I'm weird. I reply to most comments unless you're like a bad video and I hate you. But
and you're ugly.
It's only like 2%. Oh yeah, it's only like 2% of the comments, so that's good.
Terrific. All right. Well, James, thanks again for being on the show today.
Well, thank you so much for having me.
I'm Aaron Moncur, founder of Pipeline Design and Engineering. If you liked what you heard today, please share the episode. To learn how your team can leverage our team's expertise developing advanced manufacturing processes, automated machines, and custom fixtures, complemented with product design and R&D services, visit us at teampipeline.us. To join a vibrant community of engineers online, visit thewave.engineer. Thank you for listening.